I am John Mirlaws. This is our Nature Journal workshop. Today, we are checking out how to play with the equinox and the solstices in your journal. And I would like to acknowledge a couple of special guests that are on the line today. Shirley and Dave. Like you guys to, actually I'm gonna spotlight you folks for a second. This is Shirley and Dave, and they are wonderful, creative, mathematically and logistically minded folks who, behind the scenes on this, have done some incredible brainstorming about kind of what can be, how to get the most out of the next solstice or equinox. And I'm just tremendously grateful for them for being brain buddies in figuring this stuff out. So they also are going to be on call here because there may be some questions that only they can answer, and so I'm delighted to have you guys with us. Thank you so much. Really appreciate it. So we're coming up to the equinox, and if you were here for the solstice, you already have a taste, but just a taste, mind you, of the crazy things that we're going to be getting into. And so what I want to do is to we're going to sort of take a look at what's going to be going on the solstices and equinoxes, and then how to play with it in our journals. And then we've got some special bonus worksheets and things that we can be using. And I've been creating a new page to put together a whole bunch of resources for people who want to make more out of this event. And I think that solstices and equinoxes are going to be important for us nature journalers to pay attention to, because number one, we're just paying attention to the world. And when you pay attention to the solstice and the equinox, it has you paying attention to this sort of crazy relationship of the planet to the sun. And this is stuff that if you were in an agricultural society, you would be paying crazy attention to this. And so, you know, this is so cool that you're like, hey, I think we ought to pay attention to this. Let's build, I don't know, Stonehenge, right? It ends up being kind of that level of importance if you're in an agricultural society. But nowadays that things come from Trader Joe's, people are not tracking it, but it kind of just helps you get back in connection with the cycles and the pulse of the planet to have this stuff on your radar. So I'm going to just zoom down here to the globe. This is sunlight. I'm sunlight here with my hands. And if there is a time when sunlight comes, I'm on the equator. If sunlight is coming in straight like this, right? And so that means it's coming in straight at this. Actually, I'm gonna need here we go. A straight thing for folks to see. All right, this is the angle of sunlight coming into the earth. When it's coming in like that, it's coming in actually at that same angle all the way up and down and across the earth. The rays of light striking the earth are roughly parallel to each other because the sun is big and it's very, very, very far away. So far away that by the time it gets to us, those rays of light are really coming in parallel. So there's 2 times a year that the sun comes in and smacks down on the equator at 90 degrees like that. And those are on the equinoxes. And what makes this special is that on that day, the length of the day and the length of the night are the same. Then what happens is the angle of the sun changes so that the angle can become steeper that way or that way, which means that on the solstices, right, I'm going to try to get this at an angle so that, yeah. So the solstice, rather than coming in straight at 90 degrees to the equator, it's coming in at an angle. We bring that angle up on the Earth. That is the maximum tilt of that is going to be on the solstice. So sunlight coming down like this, if the sunlight is coming down at an angle like this, that means that this part of the globe is going to get more sun. This bottom part here is going to only get indirect light. And if light is coming down at an angle like this, there's a point at which the rays of the light of the sun don't even hit. They don't even hit part of the Earth. So that if the sunlight is coming in at an angle like this, by the time you get down here, you see those rays of light are not even hitting the surface of the Earth down there. And that means that it is night all day long there. Similarly, if you're way up here, you're getting sunlight all day long. So on a solstice, it's either the longest day or the shortest day. And if you are above the Arctic or the Antarctic Circle, it's a day of, you're at a time of year where you're getting night all the time or day all the time. So we're about to get up to our equinox, and the equinox, equal nox night. So it's the time when the day and the night are going to be equal. We want to get, this is when our seasons are changing, right? And it's right there in the middle point between the longest day, between the shortest day, and the equinox. On the equinox, the sun is going to rise. It's our only time of the year where the sun actually rises in the east and sets in the west. It's going to be a really fun day. So we want to document this in our journals, and we're going to use several strategies to do this. Let me jump over to my webpage to navigate you folks through a bunch of resources that are available for you. So you're thinking like, there's gonna be a lot going on here. I don't know how to memorize it all. There's gonna be a bunch of downloadable resources, and there is also going to be a bunch of online tools there that are going to help you through the equinox and subsequent solstices. Here we go. Right, this is my website. If you haven't been there before, there's a bunch of neat resources. So under the blog archives, you can find recordings of all these past classes and how to do things. There's a store where you can buy lots of neat things that help you with your nature journaling. There's lessons on how to draw, materials for teachers. Today, we're going to go over to Nature Journal, and I want to take you down to if you've been here before, you'll find that this Solstice and Equinox Journal link right down here, this is a new item, right? So this is new on here, and I want to show you what happens when we go there. So let's go there now. All right. It's text heavy. At some point in the future, I'm going to add more pictures in here, but right now, let's just be utilitarian and get that and see what is in here. So these are suggestions of what to do on the equinoxes and solstices. So the first part of it is just talking about we want to make a bunch of relevant nature observations. So what's going on with the weather? What is going on with plants, with animals, with things that you see around you? So all day on the solstice and equinoxes, any chance you get to make any seasonal relevant observations, we want to take advantage of that and do it. Now, let's check out activity number 1. And this is what we did the last time we were out there. The last time on the solstice is what kind of kicked this off and helped get this me on the radar of Shirley and Dave. the sky diagram is really, really fun. And I've blocked out, I'm going to sort of walk you through this. And then I'm going to show you an example of what that can look like. And what it is you're going to be across the bottom of your page, you are going to be making, you're going to, from, sorry, I should have my glass of water with me. If you are in the northern hemisphere, you are going to make marks across the bottom of the page that are going to start with north, and then it's going to go to east, so south ends up being in the middle of your journal, right? And then to west, and all the way over to north again on the bottom of page. And I really recommend doing this on a 2-page spread. So you're going to get north to north on 1 page. And if you're in the southern hemisphere, it's a similar sort of thing. But this time you're going to start with south and then go through east to north now in the middle of the page, then to west, and then to south again. So what's happening on the sides and the middle is going to be different. We're going to divide the page vertically into 9 bands, and these will be kind of degree marks for 10 degrees up in the sky, 20 degrees up in the sky, all the way directly over your head is 90 degrees up in the sky. So it might be useful to have your page go all the way up to 90. Not that you will get there, but that it is going to be, it's useful to sort of see, like at some point in the world, how high can the sun go? And also, if you are later on going to be putting solstices on there, and you're putting the summer solstice on, you do want to be able to go up higher. So I find it's really nice to also then do a 360-degree drawing of what the landscape around you looks like. Places where there is an open view, where you can sort of see all around you and you can spend the day, are ideal. A place that is going to get sun for most of the day is ideal. A place that is level and flat is also going to be really helpful and useful. So if you can find a place with a good view, is flat, and is going to get sun for a lot of the day, that's just great. If, however, you're living on a hillside and there isn't an ideal view and a lot of the sky is blocked by trees, but that's where you're going to be, you can set the same thing up in that location, but you just want to find a flat, at least a flat little mesa somewhere on your hillside. The flatter you can kind of get where you're taking your measurements, you're going to find that that's going to be very useful. So I like to put in this 360-degree portrait of what is going on, and I'll be demonstrating a little bit about that and how you might go about constructing that in a little bit. And then what's going to happen is on the day of the solstice, you are going to be documenting, what direction you see the sun and how high it is in the sky, and using those 2 pieces of information to draw the sun at different times across that day. There are different strategies that we're going to have for getting how high the sun is. But those are the 2 things that you're going to be doing. What direction is the sun and how high is it? And so I've got a few little things that can help you here. If you miss a few critical times and dates, there's a few websites that can help you, and these are linked there. This is one that where you can plug in your location, right? You can plug in a location, and and that will say like, okay, I am right here. And then you can put in a time and it will give you what direction to go, what the altitude and the azimuth of the sun at that particular time. So you put in different times up in here, and then you are, and it can help fill in missing pieces in your data set. Another way of doing that is if you want to get a table, in this, you would put in your longitude and your latitude, and there's a little Google map thing that you can click right here, and it will calculate your longitude and your latitude. You just longitude and latitude. You just put yourself into it, put the date, and what time zone you are sitting in, and then you hit go, and what it will do is, so let's tell this thing to execute. So for the one that it's got keyed up here for that date, here's a little drawing of what the sun is doing in the sky. And here are, here's the angle, and here is the direction. So how many degrees up in the sky and the direction. Right. So that is, this is cool because it creates a little table for you. But the most important thing, I think the most interesting thing, is for us to actually kind of generate as much of this as we can ourselves by our own direct observations and the data collecting that we're doing out there. Let me just jump over now to the webcam, and I will show you how this might look in your journal. See if I can get better focus today. All right. So this is, if I go out to the schoolyard that is near my house, I'm sitting in the schoolyard. These are trees that are closer to me. Basketball post. This is part of the school. And so across the bottom here, this goes from north to north. On the solstice, I tracked the path of the sun through the sky, and that's what I got. All right. So at different times, I'm getting where the sun is across the bottom and how high the sun is in the sky. Where those two pieces of data come together, I get a little point and I draw in my sun. So that one is, there's a little sun right there. For getting these little measurements here, what I did is I just took a ruler, and actually let me pull out a ruler. I can't find my ruler. I took a ruler and I laid it on my page, and I drew a line across the top of it, and then just moved it up one ruler length. So I would just put the ruler parallel to that line again and drew them. And I got this nice set of even lines just by taking the ruler, moving it up on top of the line that I just drew, then moving it up on top of that next line. And so that gives me my lines across here. And each one of those is 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80. The top would be 90. So that was my setup. Drawing this little drawing across the bottom was more challenging to me than I thought it should be. And one reason why it really confused me is that I was using the compass that comes with my telephone. I thought that, here's this here's this cool thing. But what I found is that when I would put it down in the same place several times, it would, a few minutes later, it would be giving me a different reading. And so instead, I found it much more successful to go old school and actually use a real compass. So what I want to do is have things like where the basketball post is, I want that to be the right distance and the right direction. So if, you know, this basketball post was at, let's say, about 133 degrees, I want it to be at 133 degrees on my drawing. And so let me just show you how I would kind of go about setting this up. It's not necessary to do this, but I found it a kind of an interesting exercise, and it was fun. So what I would do this is your journal page, and here's the seam down the middle of your book. All right. So I'm going to have north over here on this side, and I'm going to have north over here on this side, and that puts south right in the middle. I'm going to go halfway between those, and this is where east and west are going to be lurking. And so this one right here is going to be east, and this is going to be west. And then I drew a line through those, and what I did is I kind of divided these into 10, 20, 30, 10, 20, 30, 40, 50, 60, 70, 80, 90. So 90 degrees is right on east, all the way to this is in the middle is where you're going to have 180 degrees. And so you're putting tick marks all the way across. I just got out a little ruler and measured them. So I have even increments all the way across to 270 and 360 degrees. So now, I wish I had my ruler. So I took my ruler and I had a straight line across the bottom, and then I just drew a line across the top of my ruler. Then I took my ruler and moved it up one and drew a line across like that. Moved it up one, drew a line across like that. And you can do it freehand as I am here, but I found it nice to have a ruler. So, and then these are 10 degrees, 20, 30, 40, 50, 60, 70, 80, and 90. All right. So that's my basic grid. Now let's look at drawing in these different features. So there are trees, there are certain things, and I want to put those in, and I also want to get them to be the right height. And so what I would do is I would use my compass to take, now for this, I'm going to recommend that you folks get yourself a compass. And the kind of compass that I recommend that you do are these ones that have a little pivoting mirror, a little hole in them that you'll be able to sight through. This housing here will turn and swivel. And it is, hold on a second. This housing will turn and swivel. And I like to get a compass that allows you to dial in changes in your declination. So your declination is the difference between magnetic north and true north for wherever you are on the Earth. And so this compass needle that I have here does not point north. It's attracted to the magnetic field of the Earth, and that has it pointing to to something that is close to north, but not really to north. In order for me to, from where I am here in San Mateo, my compass reading is actually 13 degrees off. It's 13 degrees inaccurate. And so you can, this is not going to be a workshop in how to learn how to use a compass, but part of your homework between now and the solstice is to get that dialed in and figured out. So what I'd like you to do is to get a compass and to figure out how do you take bearings on objects with a compass. And then what I am going to do, so when I'm taking a bearing on a subject, I'm essentially pointing my compass at whatever it is, and I'm actually, you'll find out you're going to be sighting through the little hole. And let's zoom in here. All right. And do you see how I spin this part? There's a little red house. That's the dog house. And what you do when you take a bearing is you spin this to put the dog, that's the red arrow, in the dog house. If I have set this already to account for my declination, that's the difference between north and south. The difference between magnetic north and true north. When I do this, I can read right off of this arrow here that this is where I am pointing right now is 22 degrees off of north. And then what I would be able to do is come over here 10, 22 degrees. That first post would be somewhere right in here. So it's going to allow me to, the compass allows me to figure out that little object, that corner of that building right there. What direction is that? So what I did when I was making this is I shot bearings on this tree, right? On this tree, on this post, on this edge of the building, this edge of the building, this tree. So I gave myself a few landmarks where I knew exactly where they were. And then I drew those in, and that helped me get all these buildings and features in the right places. So that allows me to have the post at the right place. If I put it over here and end up using that to kind of navigate from later on, I'll just confuse myself. So getting these things in the right place, the compass was a real active part of that. Normally when I'm doing a landscape drawing, I've got a lot of wiggle room. And if I put the start of the building over here, I'm fine with it. But for this, I want it to be precise. So that's why I brought in this compass. So I'm going to suggest that you, as part of your homework, get yourself a compass. And on that web page that I showed you earlier, I've got a link to a compass like this that costs about $11. So it's a really inexpensive price point. This is basically a knockoff of a Silver Ranger compass, which will be, you know, maybe $70, $80. But this little one, it's got a really low price point. It works well, and it's going to be a fun skill to try to get. So if you want to be able to, you know, what is the bearing for this? What is the bearing for this? What is the bearing for this? That's how I figured out where posts went, but it's not how I figured out how tall to make them. What is 10 degrees here on the bottom? I have a different scale here. So if you look here along the bottom, this here is 140 degrees. This is 160. So on my bottom scale, 10 degrees is about that far. And going up here into the sky, 10 degrees is about 2 to 2.5 times taller. So I've got an exaggerated vertical scale. If I made them exactly the same, then I would be drawing the tree to scale. So for instance, if this was a round tree, which it was, I would get a drawing of a round tree. But in this, I intentionally wanted to exaggerate my vertical scale so I could track the motion of my sun with a little bit more precision. If I had the vertical scale here the same as my horizontal scale, my drawing would have fit the entire thing, the entire arc would have been only in this part of the page. But I wanted just a little bit more room to document that in. So that's why my page here has an exaggerated vertical scale. So with my compass, I figured out that my tree is here, but now I need to figure out how tall my tree is. You notice that this tree here is about 20 degrees tall from the point where I'm looking. Notice I'm not using feet here. I'm saying from where I'm sitting in this, with this scale in the sky, right? 2/9 of that, or 20 degrees here, is going to be the height of my tree. I'll be showing you ways to estimate the heights of things, so you can do things like putting these trees in just a moment. As a matter of fact, this might be a good time to go there. I'm going to jump back to sharing this screen. And I'm going to go down here to the let's see. Good. I'm going to go down here on my webpage to how to estimate or calculate the sun's altitude in degrees. And I've got several different methods here. And if you look in the corner of your screen, you can see the little inset of me. Hi there. The first thing I want to do is to show you the 1 potato, 2 potato method. This, I think, is the easiest. It's a kind of fun and intuitive way of estimating the height of an object in the sky. And you can use it for the sun, as long as you're not staring directly at the sun. You can also use it to get the heights of, say, the trees that you want in the drawings. What I do is the sun is going to be over here. I'm looking straight at the sun. And what I do is I stand with my shoulders facing the sun. All right, the sun is directly in my face, and I'm going to hold my arm out straight in front of me.
Jack, is it possible for you to just stop your share for a moment so that we can see you a little bit larger?
A little bit larger? Well, let's go for the big Jack.
Okay.
Big Jack. All right. All right. So let's check this out. So here's what I'm going to do. I'm standing, my shoulders are, the sun is directly in front of me here. And what I do is I look across the ball field at a point that is at the same height as my eyes. That's going to be my horizon line. So the horizon is just a projection of where your eyes go out into space. So I find some object out there that is the same height as my eyes. And what I actually did is I walked across the ball field. I tied a bandana on a branch that was at the height of my eyes. Or you can just kind of look across the ball field and say, you know what? Your eyes are about this height across there. And with the precision of this approach, it's not going to be a problem. What I did is I took my fist out and I rested the bottom of my fist on the bandana. So my fist is starting on top of where my eye level is. All right? And this arm is straight out, closed fist, and I'm putting it in the center line of my body. So if you're looking at me this direction, it's just like that. So I'm not out here, it's just in the center line of my body. And what I'm going to do, looking at the sun, is here's this fist length projected into space is about 10 degrees. So anything that is at the height of that fist, that's going up 10 degrees. And then what you do is you do 1 potato, 2 potato. That is 20 degrees up into space. 30 degrees. All right? So you can 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees to your zenith right over your head. You're going to find that this technique is better for things that are closer to the horizon. It gets much more difficult as you're kind of up here and you're doing that and you're kind of wondering, like, did I move, kind of bend my elbows some, and you know, you're kind of so it's harder to do the 1 potato, 2 potato method for things that are really high in the sky, but it's great for things that are low and close to the horizon. It works really well. 10, 20, 30, 40, right? That's the 1 potato, 2 potato method. And so you see what I did with these trees is I just got its location. And then this one here was a little bit less than 3 fists tall. So I made this one just a little bit less than my 30 degrees. And that's how I got the height of my trees. So again, a weird thing about drawing this picture is that, let's say there's a round tree. If your vertical scale is exaggerated, that round tree is going to be a big vertical bush like that, because you have an exaggerated vertical scale, so you'll have more room to show all your stuff that's going on in the sky. So it is a little bit of a brain bender to make a chart like this, but that's one of the reasons that I like it. I like to do things that kind of get my brain going, like, oh, ah, like, ooh, ah, why does, oh, okay, ah, I see. That's what I want going on up here, right? So that is how I draw those in, all right? So that's technique number 1. Now, we're going to check out technique number 2. Technique number 2 is really, really, really cool. And technique number 2 is a little bit more difficult for things that when the sun is really low in the sky, and is awesome when the sun is higher in the sky. So these 2 techniques, one is really good when it's lower, one is really good when it's higher. And when it's in the middle, you can use whatever you like to do. All right, let's jump back to that screen share. I'm going to show you. All right, so here we are. So that first we had 1 potato, right? This next one is so cool. It uses trigonometry and tangents. And we haven't gotten to play with this stuff in such a long time. And so what you do is, so the instructions for it are right here. But I'm going to, over on my piece of paper, I am going to sort of draw out how you would do this. For this, what you need to do is you need to have a vertical pole that is in an area that is flat, right? A vertical pole in an area that's flat. And let me see here. Stop share. I'm going to go to, oh, not that. So here you are standing on the playground. And there's a volleyball pole that's right next to you here. Or maybe you're out in the field and there's a fence post that's right there. All right. The sun is up here in the sky. And the sun's rays are coming down at, by the time they hit us, at this sort of parallel angle. So off the top here, that sun's rays is going to project a shadow onto the ground just like that. So what I am going to do, this by the way, if it's a well-made volleyball pole, that's 90 degrees right there. I've brought my measuring tape with me, right? And so here's my little measuring tape. And what I can do is I can measure this pole. And I now know that this is a 7-foot pole, right? Or 3.5 meters. I do recommend we actually use metric for this. So I would suggest, but you can do whatever you want. So measure this either in centimeters or in inches. And actually, let's not say 7 feet. Let's say, let's because I am in the United States here, and I'll use inches here. This is 80. This is a pole that is 87 inches high. All right. Now I measure this shadow length here. It's a good idea to get a little piece of chalk and to mark that on the ground. You then get your shadow length here. And let's say this is 102 inches. I now am going to do a little division problem. We're going to call this A here, and this is going to be B here. So my formula is going to be A over B, which is going to equal 87 over 102. And that will equal, somebody who's got a calculator out, what is that? So we're talking 87 divided by 102. I don't have a calculator handy. Somebody's got to have it. Well, let's call it a number. All right, so it equals some number. So I do this little division problem and I get some number. And what I do then is
Jack, it's
here we go.
It's 0.85.
Happy equals 0.85. Right, let's say I got 0.85. What I do is I then take that and I plug it into a tangent table. And I am going to go, so it is, here would be 0.8, so 0.85, 0.85.
You need to keep going.
Oh, there we go.
Second column.
Yep, so there we go. I'm looking for 0.8, 0.83,
853.
So I'm gonna figure out which one of these is the closest. Which one do you like, Melinda?
I can't see the numbers.
Oh, so I have a choice between 0.83, 0.86. Let's call this 0.861.
That's good.
Yeah, so that's gonna be 41 degrees. That means what this does is it takes that number that I just calculated and it turns it into an angle. That all happens inside the magic of this little table. So that means that this angle here is 41 degrees. And that means that the angle to the sun is 41 degrees. So through the magic of trigonometry, we have figured out how high this bad boy is. Isn't that cool? And something I like about this is that I have not used trigonometry in a very, very long time, but I bust this out and all of a sudden, wow, that's really cool. I like that. All right. Then, actually, there's a few other techniques that are. There's one other technique that I want to walk you folks through. But first, let me see. I'm going to jump back to this. So the instructions on how to do that are right here. Here's another way of doing it. I've made a little converter here. If you type your shadow post height into here, so let's say your shadow post height was 87, right? And the shadow length was 102, right? And here it is. This is the angle of the sun in degrees. So it automatically calculates that for you. Isn't that neat? It took me forever to try to get this thing on my computer to do it right. And thanks so much to Dave and Shirley for helping me figure out the formulas. We have another fun technique here, the post and rope technique, which you can read. This is great if you're doing this with a large classroom. And want to have something where you kind of have students engaged holding ropes and pulling them around. And this is a little converter where you can put in your post height, and you want to figure out where should you put a marker in on it that is to be, so this was, let's say, an 87, how far out should you on your rope put so you wanted to find out where 40 degrees was, you would go out to 103 inches, right? So this does the same thing in reverse if you want to turn a rope into a little marker for degrees. That'd be fun if you have a full classroom of people kind of running around. The last is one that Dave and Shirley came up with, which is just brilliant and does not involve staring at the sun. And what it involves doing is using a compass. And let me see here. So if you look at this compass, there is, actually I'm going to turn it this way. All right. If you look on the compass here, do you see this little red arrow that is always pointing down? Not the north-south arrow. There's this other little separate arrow here.
Jack, can you move it up just a little bit? The other direction. Move it.
Oh, there we go.
Maybe sideways. It depends on where.
Like, you see this arrow over here? Now, okay. Now, hold on. Let me see if I can make this work. Will you focus on it? Maybe if I put something white behind it.
Okay, we can see.
All right. So there's a little red arrow.
Move it up a little bit. There we go.
So there is. No, this is not working. Okay, scratch that idea.
Jack, I just wanted to make a note here. Ray Bonto noticed that the table that's linked to your website is a cosine table and not a tangent. So that'll just need to be changed later, but I put it into the chat so that folks have a tangent table instead.
Oh, dude, thank you so much for pointing that out to me. I will fix that. So the So I think actually what I'll do is I'll post a little video about how to use this, but it is going to, let me see, I need to switch the video. With this technique, you end up using the compass and sighting through the little hole in it down to the shadow of your head on the ground. And you go halfway through the shadow of your head. That's where your eyes are. And that's, you aim at that. And then in the mirror, you can see where that little plumb bob is in degrees on your compass. So it's the little arrow just sort of points down towards the center of the earth, just like a plumb bob, and you get to see where that is in degrees. So you're aiming at the shadow of your head, and that ends up giving you the angle of the sun projected through your head out the back from down there on the ground through your head. That's just, it's pretty cool. So mad props for that. So there's several different strategies that you can use for doing that. And you don't have to do all these things, but what I do recommend doing is just sort of playing around and seeing what is really fun. The final thing that I want to show you, and this is where Dave and Shirley just rocked my world. They came up with this idea of the sun target, right? So here they are, Dave and Shirley. You're even on the page here. Thank you guys so much. So here's the sun target. What you want to do to do this, all right, you are going to first print out one of these, all right? And these are 4 different targets, 4 different targets that for different places on the earth, whether you're in the northern hemisphere, some work north and south, was one that just works in the northern hemisphere. But some are a little bit easier to use if you're closer to the poles, others if you're closer to the equators, others if you're in middle latitude. So you're going to choose which one of these you want. If you are in the northern hemisphere at sort of mid latitude, say somewhere in the United States or parts of Europe, and you're checking in from there, there is one that is specific. It's a sort of asymmetrical one that you can pick out there. As long as you're below 45-degree latitude in the northern hemisphere, I would pick that one. Then there are these other ones that you can use either northern or southern hemisphere, and there you're just picking high, low, or mid latitude, right? So step 1 is you get yourself a target. Now, oh, this is going to be so fun. So right now I am crawling underneath my desk and plugging in my hot glue gun. All right. This is going to be beautiful. So check this out, because you're going to want to do this. Take a look at the targets. Second. Need to make sure my hot glue gun doesn't drip all over my desk. All right, so here's the target. What you're going to be doing, I'm going to choose one of these targets. So here is one for mid latitudes. Here is one. You'll see that the differences between these high latitude. The high latitudes, these circles are smaller. All right. Mid latitudes, they get a little bit larger, and then mid latitudes, and then for the low latitudes, here we're only going out to, so low latitudes, here's 20 degrees is this circle. And 20 degrees is this circle in the mid latitudes ones. And finally, in the high latitudes, 20 degrees is in here. So you see that this one here for the high latitudes, you're going to, it's going to go, you go out you go out further to degrees. What's going to happen is you are going to glue a post in the middle of this page. Orient the page to true north. And then you're going to just draw in on it whatever the shadows are doing at different times of the day. I'll show you the one that I'm going to use. I'm going to use this Northern Hemisphere one. And here's the way you use it. Look at this. Over in the corner of it, there's something that says length of shadow post. And what I'm going to do is I'm going to take a little toothpick here. And I'm going to mark it for the length of that shadow post. And, oops, my shadow post went flying across the room. I'm going to do it the other way. It's time maybe not to lose my shadow post. Oh, no. So from the tip of the arrow to the tip of the arrow, I really want to make sure I get this accurate. What's kind of cool about this is that you could take this same page and when you print it out, you can enlarge it or reduce it. And the shadow post measurement also will enlarge or reduce with that. And so this whole page can be made any size you want. If you're doing this with a big class, you can make a really big version of it. Or I've actually done a smaller reduction of it so that I could cut this out and then easily paste it into my nature journal when I'm done, because I've got an 8.5 by 11 nature journal. What I'm going to do is put a little squeeze of hot glue in the middle. And then put my post in, pointing straight up, right there. All right. Now I let it dry. And I just want to make sure, check it from a bunch of different angles. I want to make sure that that post is really straight up. Now I'm almost done and ready to use this target. The next thing I'm going to do is I am going to mark in over here my change in declination. So where I live in San Mateo, true north is 13 degrees off of magnetic north. And so what I have to do is on this, here is 5, 10, 11, 12, 13, right there. I am going to take a straight edge. Line it up there. There. There's my 13 degrees. If I have a compass where I've already dialed in and you learn how to kind of pre-dial in the declination, then I can align this compass using, but just by putting the edge of my compass along the north arrow and spinning the compass and the paper until I put the dog in the doghouse. That is, that I put There. So you're going to align this. So I want you folks to kind of study up how do you align a map with a compass. If you're doing something with a pre-dialed in declination, and you can do that on these compasses, then I would dial the 13 degrees into here and then get that. Or if not, then what you can do is just put the side of the compass along this 13-degree line and spin the compass. This 13 degrees is now taking care of that declination for you. In either case, you're going to align your compass, align this piece of paper, so that north on this piece of paper is facing north in real life. And then what you're going to do is just wherever the shadow is on this piece of paper, you draw a line from the post out to the tip of that shadow. So let's see if I can, where's the little flashlight? Here we go. See if this will work. Not very well. Yeah. All right, so I should get a more directional thing than this. All right, but if you look over here, you can see a little shadow coming out this way, right? What you do is you just along that shadow, in the middle of that shadow, draw a line and stop it wherever the, I'd actually planned to have, to take you folks outside and put this out underneath the sun today in this workshop. However, there's so much smoke in the air that you really can't see your shadow right now.
Jack, you could use the flashlight on your phone if you have that handy.
Oh, that's a great idea. Phone. There's my phone. All right, so check this out. As the sun moves around the sky, the shadow changes its direction. And as the sun climbs higher in the sky, the shadow gets shorter. So when the, so let's do it this way. So let's say early in the morning, all right, this is what I would see. So from wherever I am, I would draw a line from here down like that. And I would write in the time that this was at 9:30. All right. Now the sun moves and it gets a little bit higher in the sky. Notice that it now has a new time. It is now going to be 10:30. And then it moves further across the sky. I missed a little reading in there. So I'm coming back out and it is 1 o'clock. All right. So what I'm going to do is I'm going to get all my readings throughout the day, all on this same piece of paper. Critical things to do would be to align. I want to always make sure my piece of paper is aligned with to true north. Get that date in, and then just draw on the little line. And here's what's, so you can do this, of course, with just any piece of paper. But what makes this so cool is, this is what Dave and Shirley did. You take a look at these lines, and each one of them is on a little number. This one here, so this one here at 1 o'clock, it was coming around right here, that's on the 50. That means at 1 o'clock, the sun was 50 degrees up in the sky. These numbers on these circles are give you the degrees that the sun is in the sky. So when it was, if it's out here on this big line here, that's 15 degrees, here's 20. At 9:30, we had it halfway between the 20 and the 15. So 15, so maybe that's 17 and a half degrees. So that can tell me, this chart tells me how high the sun is in the sky. The other thing that it does is, if you look at this ring here, that's a 360-degree circle. And I can use that to figure out north, south, east, and west. So actually, I'm doing this upside down. So if I have a line that is pointing out this direction, that would actually be pointing due south. So this pattern, by the way, this pattern of lines that I'm getting here is not, I'm not sort of paying attention to like how this actually would have formed on a real day. But you see how you can follow each one of these lines out, and that will tell you north, south, east, west. That outer ring here tells you what degrees you're on. So here is north, here's east, here's south, here's west over here. So in real life, the shadows in the morning are we're probably going to expect to see them coming out. The sun rises in the east and sets in the west, so that the shadows would be coming out in the morning out like that. And then kind of going on from there. So just ignore the locations of these, but you see how this target here then allows you to get both the altitude of the sun and the direction of the sun. It's just such a brilliant, elegant little idea. And then I can take this piece of paper when it's all done, and I can cut it out and I can glue it into my journal along with the rest of my notes. This is new. We didn't have this on our last for the solstice investigation, but it's a beautiful, beautiful idea. I'm going to bring Dave and Shirley on now for a moment if they want to make any comments or other thoughts here. They really have been thought leaders in developing this, and I should definitely not take the bow for coming up with this beautiful. What I want you guys to notice is also just the thinking behind having come up with something like this. I absolutely love it. So. Dave and Shirley, welcome to the Nature Journal Workshop.
Thanks, it's nice to be here.
Do you have any other sort of thoughts, comments, or ideas about using these materials that we would want to share here?
I think one thing is that the potatoes are still probably your absolute best bet for lower sun angles. As the shadows get longer, they become less crisp and it gets harder and harder to mark. So sometimes simple things work the best. And the potatoes work particularly well because they use exactly the same principle that's in this chart. It's simple trigonometry, so that your hand from here to here has a ratio of the length from here to here. And whether you're 10 years old, 3 foot tall, or 6 foot tall, you still have the ratio. So the 10 degrees is still 10 degrees because of some very nice trigonometry. There was a question about, I don't quite understand the north line on the right side in connection with the shadow line. You're not the first one who's had that question. We had to go through that several times. And at one point we had the numbers running the wrong way around the clock. We're trying to measure the sun's location relative to a point based on its shadow, which heads off in the opposite direction. So the north arrow is where the whole paper has to aim in order for the rest of all of the shadows and angles and things to work out. I hope that helps some on that. Yeah. And in terms of figuring it out, it was trying to find a way to spend more time observing so that my nature journalist could spend more time drawing and less time measuring.
Yeah. So yeah, the wonderful kind of brain flip there is that it's not which, when you're looking at the direction that the shadow is going, that's opposite than the direction that the sun is.
Exactly.
And so if the sun is rising in the east, its shadow is pointing to the west. And so that, yeah, that's just the mental gymnastics that you guys had to go through to come up with this target. It would be fun to kind of be inside your brain.
I had a full head of hair when I started.
I would add one tip too, to help people in the northern or southern hemisphere. When you're setting yourself up, let's just assume that you have a little picnic table or something and you've set your target out on the table. Regardless of which hemisphere you're in, you're going to want to be facing the equator. And that way your body's not going to get in the way of your shadow. It's not something you have to do, but if you're setting up like I did and you want to be doing a bunch of measurements, it works out quite well if you do that. Did that make sense?
Absolutely. Yeah, you don't want your own body to be in the way of the light that you're using to draw those shadows. Yeah. Are any other thoughts or ideas for us, Shirley?
Well, just, we've just been doing this over a very short amount of time, and it's been a lot of fun to stumble along and get things working a little better and a little better. But if you stumble, I would encourage you to have fun with learning it and figuring it out as we did. And you might have to say, there might have to be several other versions before we get everything working just right. So don't assume it's perfect yet.
If anybody wants to chase down the mathematical rabbit hole, I sent John some files. These templates that you have are generated with a tool called FreeCAD. And there's a lot of math in there. Someone on the chat had commented, a little like a sundial. The sundial community is incredible, and they have all the math you need to be able to figure out all the distances and the angles and things you need, because this sort of thing isn't actually plane trigonometry, it's spherical trigonometry. So yeah, it's a little like a sundial, and there's a lot of fun things in there, but I tried to make it so that the paper that it ended up with would insulate you from a lot of that detail and make it possible to, again, measure less and observe more.
Yeah, it's just a brilliant idea. So here's the kind of my suggestion for your ethic on the day of the of the equinox is just be like, have a bunch of stuff ready and kind of mess around with things and see what works. I do suggest testing things out, like, you know, how can you figure out how a compass works? How do you take a bearing using a compass? I was thinking of making some tutorials myself, but then I looked online and there are tons of really good, you know, the Boy Scouts make great tutorials on how to take a bearing on an object and how to use declination to orient a map. So there are some really quality videos, and I probably will be linking to those pretty soon off of this page, that can give you some nice instruction on how to do those sorts of things. But day of the equinox and the solstice, just be ready to mess around with a bunch of this stuff and like keep drawing the sun at different positions in the sky, catching shadows. And then what we're going to do is we're going to have probably 2 post-equinox after parties. And in the after party, what we do is we're going to get people all over the world to call in and show us their notes and their observations. And we will compare the different sorts of the sun maps and sky charts that people made at different locations all around the planet. So we've got people in the northern hemisphere, southern hemisphere will be sort of checking in, and it just kind of allows us to wrap our head around this crazy business a little bit more. So there will be 2 post-equinox after parties. I do recommend that if you did document the sun before in your journal, you can use the same page to do that again. And then you'll have the solstice and the equinox on the same page. We'll do the same thing again at the winter solstice. And that will be the shortest day of the year in the northern hemisphere. And so it just gives us more of a chance to mess with this stuff and play with it. Part of what I like doing is exercises and procedures that stretch my brain and make my head hurt. And thinking about this sort of stuff is great, is great for that. Because in those sort of moments of struggle are those times where our brain is going to be learning more. I hope that this was useful in giving you a few ideas in how to get ready for the equinox. The reason we are doing this so far ahead is this gives you time to kind of order a compass, figure out how to use a compass, and print out one of the charts, try orienting it, sort of see how it works, glue a little post onto your page, and it's going to be fun. I hope that this was enjoyable for you, and thank you for joining us with the Nature Journal workshop. Right before the equinox, we're going to have one more workshop, this one on a Thursday. We'll be going over a lot of the same material. I may have sort of refined a few kind of teaching points or ideas by then. But let's be ready for this, and let's get out there on that day and be ready to play.